Introduce Mr. Alex Spadaru, who's the president of the ADEPT group. Alex has been involved in a number of liquefied natural gas and propane gas technological advancements, and he has been involved in a whole range of other interesting things. He's an inventor and has been for a long time. He's been involved with government and private industry and a whole number of other very interesting sidelines. As this relate, I will dispense with the long introduction, and if you need more information about Mr. Spadaru's credentials, there's a notice on our web that you can take a complete look at his bio. And without further ado, I'd like to introduce Mr. Alex Spadaru.
Thank you. Thank you, Steve. Thank you for being here. Hello, ladies and gentlemen. And I will begin my presentation. This presentation is about a product that was developed with ICAT money, and it's called the Stop Fill Instrument. And the title of the presentation is Measurement and Reduction of LP Gas Outage Gauge Emissions. We will proceed. What are the objectives? They are to describe work conducted under the ICAT grant with the ICAT grant money, essentially find out what ARB got for its money, describe the emissions that occur along the typical LP gas distribution channels in California, and show how this instrument, the SFI, can eliminate the significant portions of these releases. Why should the refueling process of LP gas, why should these releases be eliminated? There are essentially 5 reasons. They contribute to air pollution. It's a blend of VOCs, and it's got a GWP between 3 and 20, depending on where you go look it up. They represent a proven fire hazard. They waste a valuable energy commodity, and they can be a health hazard to the LP gas delivery personnel. And they frequently cause the loss of already paid for product for the end user, who pays for but never gets to enjoy it because the releases often occur after the meter. The problem, LP gas emissions while refueling are a significant air pollution source. Everybody knows that LP gas leaks whenever a tank or a cylinder is refilled. It is a fact, proof of which will be described in a moment, which is based on uncontroversial evidence. I said it, that these are significant releases. What has complicated this matter up to now is that there's been misinformation, number one, on what are the real mass releases through the outage gauges, and 2, what are the actual field refill practices. Thus, the problem at hand was to quantify these releases and to come up with one possible cost-effective corrective action. It would be irresponsible to further ignore these releases and to fail to provide cost-effective prevention. The solution? Well, it involved to measure these releases and to take proper corrective action. This entails 3 steps. Scientifically measure the mass release rates for the outage gauges. 2, quantify these collective releases for specific tank populations. And 3, develop and prove a technology-based 21st century practical solution to eliminate completely the need to open these outage gauges while the tanks are refilled. Today, there exist several technologies that can remedy the situation. One such method will be shown in this presentation. Am I going too fast? Thank you. Okay, the urgency. The damage is occurring now and has been going on for decades. Given that the technology-based solutions are both cost-effective and are available, there's every reason to upgrade ASAP refilling practices that have been unchanged since at least 1962. Now, 1962 is in there because the first time I actually saw a propane tank being filled. That's why it's 1962. Okay. Question, is this a widespread problem? The answer is yes. Okay. Here are visual reasons why one needed to come up with something to avoid these releases. These photos allow the viewer who's not familiar with the industry to understand what are some of the common terms and how the procedure occurs. These are available on the net, so we don't need to really go through them at length. Again, these are some of the sequence of events that I think should be looked at. When you first open the outage gauge, there's a little liquid and vapor that comes out because it's been sitting for a while. Then that's a very small release. And then you have gas phase release. And then when the liquid reaches the bottom of the outage gauge, you have mostly liquid that comes out. Okay, what do you typically find in terms of the gas compositions in California? And these are some numbers that you will find if you look at various standards that are practiced in California in terms of fuel quality, or an actual test that were conducted over the years that we collected. Anyway, all these gases are greenhouse gases, they're VOCs, and about 10% are reactive organic gases. Okay, this is your typical distribution channel and the distribution path for propane. And again, this is available on the net, so we will go through this, okay? What are the points where LP gas occurs daily? At refineries, at natural gas liquid plants, pipeline terminals, rail cars, port terminals, propellant plants, bulk storage distribution plants, transport vessels, bulk transport, bobtail transport, and then you have refueling at industrial sites, commercial sites, residential tanks, barbecue tanks. These are the 20-pounders. You have 20-pounders being refilled at central plants, which are typically done by weight. And then you have local refueling that you do at the local gas station that can or cannot be done by weight, depending on the local conditions. I think there's actually a mandate to do it by weight, but I'm not sure. You have automotive fleets, buses, shuttles, forklift trucks, where you have refueling, and you have other equipment that are built on tanks that must be refueled. They're listed there. Then the points of transfer, this is a non-exhaustive list of the points of transfer where these releases occur. With the exception of the last point, there are significant LP gas outage gauge releases at each of the above listed points of transfer. This is a typical outage gauge. What are we talking about? The outage gauge. Well, that's what it looks like. Of course, it's blown up larger than it really is, and what's missing is a tube down the middle. And that tube down the middle is not shown because it can be of varying length, depending on where the 80% full level is inside of a tank. What is an outage gauge? Now, outage gauge can come with many different names. It can be a fixed maximum fill level gauge, a fixed liquid level gauge, an outage gauge spitter valve, etc. The most common name is outage gauge, so we will stick with that. An outage gauge is a valve with a .055 diameter hole drill size flow restriction within. The valve is connected to a tube that extends downward into the tank to the 80% full level, which is the usual maximum fill level for LP gas tanks. This tube is typically left open, fully open during refilling, venting gas phase LPG until liquid rises to the bottom of the outage gauge tube, at which point liquid LP gas is observed to escape through an orifice at the top of the outage gauge. The emitted white cloud is a mixed liquid and vapor LP gas signals that the filling must be stopped. It's white because typically it freezes the water in the air, so that's how you get this white cloud. The outage gauge signals when the liquid LP gas has reached the maximum safe fill level. Well, again, there are essentially three phases that you can notice this release in. One of them is gas phase, a mix of gas and liquid, and mostly liquid. How do you calculate what these releases are? It's simple. You calculate the number of seconds that the gas phase is being released, and you add that to the number of seconds multiplied by the mass flow rate while liquid phase is released, and you add the two up, and you end up with what the amount of the mass that was released. Again, the little blend, when you have a little bit of, when you have even distribution of gas and liquid phase, that's a very short period of time, so we chose to ignore it. Okay, there were, so measuring these K factors, measuring what the mass release rates was an essential part of trying to quantify the problem at hand. So the first time that we did that was in January of 2008. And at the first test, there were folks from AQMD and ARB that were present. And you can see in one of these pictures how the liquid phase release was measured. Again, this emission mass flow rate is called a K factor. And this K factor depends on three items: pressure, temperature, and the surface of the outage gauge opening. And we will discuss each one of them. The number 54 drill size opening is constant across the United States for all tanks and cylinders, except for rail cars where it is much larger. The K value measurements were taken with ambient temperatures from 68 to 72. And the Ks were measured at various pump pressures and without pump pressures to gravity fill. All the work was done on forklift cylinders. Okay, what did we find out? We found that these are averages. there's papers on our site that could show all the details, but what we end up with is roughly 3 grams per second when you're dealing with pump-assisted and gas phase, and 2.5 grams per second when you're dealing without pump-assisted or gravity fills. And then in liquid phase, we couldn't measure what it was liquid phase with pump assistance because it went way past the scale of what our instrument could measure. But when we're dealing without pump assistance, we're dealing with 10 grams per second. So for purposes of our calculations, we decided to be conservative and stay with 10 grams per second, even when we're dealing with pressure with pump assistant conditions. Again, what are we looking at in California, where we're assuming a 70 Fahrenheit average? You're looking at 10 grams per second liquid and 2.5 to 3 grams per second vapor. Here's a diagram of the test equipment. We had to design this from scratch. We used a technique that was previously used for natural gas measurements, emissions. Again, if you want details, you can look it up on the net. This is what the equipment looks like. It's innovative, it's creative, it's great. We designed it. Here are some pictures of the actual test conducted in a sequence series on November 4th of 2008 when we went there to do the gravity fills measurements. At that time, we were fortunate to have the Southwest Air Quality Management engineers with us that conducted their own tests. And these pictures will show, again, the photography is not great, but you get the idea. Again, this stuff, you can find it on our site. It'll be available afterwards, I assume, from ARB. So we will skip through these photos rather quickly. We hired this guy from Central Casting. All right. We have estimated cumulative releases. Again, forklift cylinder refills, we calculated for California, you're looking roughly at 15.6 tons per day. And for the AQMD territory, you're looking between 6.2 and 7.8 tons per day. For stationary tank refills, these are the tanks that you find at your residences, businesses, etc. We calculated that in the state we have 26.8 tons per day being emitted. And then on AQMD's territory, we found around 10.7 tons per day. And then we didn't have excellent data on the other populations of the tanks, so we made an estimate based on some prior work that was done for the LP gas industry study in 2005, and we came up with a rough estimate of 110 for the state of California and 43 tons per day for an AQMD territory, where you end up with 150 tons per day in the state of California, which is essentially the next slide. And then this was something funny happened, which was this was the announcement, the initial announcement for the seminar, and it reads Maximum SFI measurement and reduction of LP gas outrage gauge emissions. Anyway, I think that was a Freudian slip. All right, let's see where the stop fill instrument fits and how it looks like on a tank. You have here a picture on a 2,000-gallon tank, and then you have another. What is a stop fill instrument? It's a non-invasive instrument that can eliminate outage gauge releases while refueling stationary tanks. It is handheld. It is interactive. The operator has to punch a couple of buttons. It is battery powered. It readily attaches to horizontal stationary tanks with magnets. It's easy to put on. It's easy to take off. It signals when the liquid level inside the tank rises to the line wherever you put it on the tank. So if you want to do a partial fill, a partial load, you know exactly where to stop because you know the geometry of the tank. So this becomes a very accurate means of delivering as well as eliminating an emission, an undesirable emission. Okay, what are the features? It is accurate. It is reliable. It uses 2 redundant techniques to detect the liquid level, because when you do that, you cannot afford to have any risk whatsoever. So we combine 2 different techniques that come together, and they give you the same result. So then you know you got it nailed. With this instrument, you do not have to open the outage gauge, and no extra LP gas delivery time is required. It's essentially the delivery, we try to do it in such a fashion that there's no additional time and it's totally transparent to the operation. It requires a bubble level. In a future design, when we actually further refine the product, the bubble level will be incorporated in the instrument itself. You see it right now, it just sits on top. It's a 10-cent piece of equipment. Okay. The tank plate information, you need to have that on tank by law. The tanks have to have a tank plate with tank information. So you have the tank diameter and a shell thickness. This entails an additional amount of work that will have to be done, which is essentially record what each tank has as in terms of tank diameter and shell thickness. Some propane dealers may not have that information tabulated. It's not very hard to do. And it requires a short training period. What did it take us to get here? First, we needed to do some lab bench tests to see that it works. We needed to do some initial trials. We did some secondary field trials, and then we finally did the final field trials. And here are again, a photo of the initial field trials, the second field trials, and then these are some of the photos that show you what's being indicated on the display. And this is you're looking at here at a tank that's about 1,000 gallons. This is second field trials. And again, the second field trials, this tank looks like it's about a 2,000 gallon tank. You can see the buttons where you have to be interactive. You have to input the tank diameter. And in this particular model, we have to put the tank diameter in the tank. Shell thickness. In the future, if you know where you are, you just simply punch in the tank number. All these tanks have an identification. Automatically puts it in. Again, you notice a little bubble on top. It's got to be horizontal. And it gives you the temperature as well. And it slices, it dices, and all that good stuff. Okay, here is the final version of the stop fill instrument. You can see that it's larger than it's about 18 inches in length, and diameter is about, I'm guessing, about 1.5 inches, and it's got a thickness of about 1 inch. I'm guessing here. Actually, when you can go on the net and see the measurements, there's a scale there. So these are guesses. I should know it, but I don't. Okay, and these are some various tanks on which it was tested in near our shop. This explains the fact that we use 2 different techniques. You can go on the net and see exactly what these techniques are. And then, what are the potential benefits? With current refilling practices, the environment is damaged, energy and money are wasted, and unnecessary risks are taken. Until now, there was no practical means to avoid outage gauge releases with current LP gas filling procedures. The broad use of the Maximus SFI in California will help eliminate about 45 tons per day of VOCs within 1 year. Again, conclusions. LP gas leaks through the environment every time a tank or a cylinder is refilled. Depending on your point of view or who you work for, such releases range from significant to huge. Appropriate technology is now available to address this problem. With the Maximus SFI, the bulk of these outage gauge releases can be eliminated in a cost-effective and timely manner. And there is a clear urgency to address the above-described problem. Work presented today was conducted with funding from CARB under the ICAT program, from DOE under its Inventions and Innovations program, and with money from AQMD, which was co-funder with CARB. We thank you for listening to this presentation, and we also wish to thank CARB, DOE, and AQMD, and all the folks who helped along the way to help us get to where we are today. Come on. The sound isn't there? Not too bad, because I had applause. This thing's very good at applause. Didn't work. Thank you. Thank you, thank you, thank you, thank you. The next slide is Q&A. There it is.
Any questions?
And notice there's a flag in the background, so this is very patriotic.
Hang on, let's get over here first.
Hi, I'm Leslie Garland. I'm the president and CEO of the Western Propane Gas Association. I have a number of questions, and I can go through it systematically through the presentation if you'd like. Is that the easiest way for you?
Whatever way you want.
Okay. Starting on slide 3.
Slide 3. Let's go back.
I was wondering what academic source you were talking about in terms of greenhouse gases, because according to a United Nations Intergovernmental Panel on Climate Change report, they made it very clear that propane is not a direct greenhouse gas when released into the air.
Okay, you will notice something called GWP, Global Warming Protocol. That is how you assess. Say again? For potential. Actually, it could be both. Okay, whatever. We'll go potential. Okay. GWP, I participated in a lengthy dialogue with a number of academicians that sit on that panel. And there are references in various documents. I'll be happy to give you the references where you end up having values from 3 to 20. When you're looking at natural, CO2 has got this unit of 1. When you look at sulfur fluoride has got a number like 22,000 or something like that. Okay, these are really nasty products. Propane has got a 3 to 20. It's not. It's all graded. It's more than CO2, but it's less than methane. It's still there. It still contributes something. It, for instance, interferes with the way methane is absorbed, breaks down, oxidizes, and as such, it contributes to the global warming. These are some of the things that I learned while digging into this.
Okay, well, I was digging into it too. The report went on to say that because the propane vapor is unstable in the atmosphere and is removed faster than it takes for it to become well mixed and have impacts on the global climate. So the current measurements have not found that a global climate impact from these propane emissions. This is what the report says. So
well, you know what they say about opinions, right? So the point is, the point is that I admire I think it's good that we're having a dialogue, but the research that we conducted indicates that 3 to 20 is the right range in terms of GWP.
Okay, and then going down to number 5, where you cite the end user who pays for it but never gets to enjoy it. I do appreciate that that is the fact. However, some of the reports that you were citing, a majority of the losses occur upstream from the consumer at the refinery or the wholesaler level. And on average, one of the reports from PERC in 2005 and from WPGA in 2005 showed that the average that was lost at the residential level was 195 cc's, which is a couple of tablespoons full.
Well, I understand that, but at that time, I don't think that report knew what those mass release rates were. I think they were operating on mass release rates that were practically half, because they were operating on data that we originally provided. That's how I know that.
Okay. Well, going on to slide number 6.
Slide number 6. 6 coming up.
It is. You made the comment that it's unchanged since 1962, which was when you first got involved in the propane industry.
No, that's the first time I saw it. I was living with a family in north of Pasadena. That's how I got to see it. They had a tank.
I don't know if you're aware that the Certified Employee Training Program, which is the propane industry standard for
I think
training,
that's wonderful.
There has been, over the past decade, they have changed the training to ask operators to open the outage valve when they begin the transfer process, to verify that the outage gauge is working, then close the valve, keeping an eye on the gauge, and when you get to 80%, you crack it 1/8 of a turn, and then when you see the emission, you then stop the transfer process.
I think that's fantastic, and I think it's great that it's in there. But what happens in the field is not what happens in a book. I know that because
it's not in the book. That's part of the
whatever,
training.
Part of the training. That's what I mean.
Okay. Well, when we're talking in generalities, I was interested if you knew that there was specific training to tell or not to.
Absolutely, I knew there was training. It's just that it's not what happens.
To slide 11.
Slide 11.
I also just wanted to point out that when we're talking about the propylene, a considerable amount of the propane that comes to California is from gas plants, and there is no propylene from the gas plant propane.
That's absolutely correct. About 50-50 comes from gas plants, 50-50 comes from gas food. So there is evidence, there is data that points out that you end up with that amount.
And again, the greenhouse gas issue that I spoke of earlier. Slide number 12. This production and distribution paths, just for clarification's sake for those of you who might not know, in California, there are no ships, there is no underground storage, there are no pipelines. So you can basically skip straight from oil well, refinery, and gas plant to the transport and the rail car spot. In California, okay, sorry. In California, on these pads, there are no ships for imports, there is no underground storage, and there are no pipelines. So basically, you can go from gas well, oil well, gas plant, refinery, and go straight to transport rail car. And import would also include the rail car. Slide number 18. Just again to reiterate, when it says this tube is typically left fully open during filling, again with CTEP we are enforcing training in the field to discourage that. On slide number 22, on bullet point number 1, there's a reference to the 54 drill size being constant across the country. There is, Marshall Excelsior markets a device that has a 72 drill size. I don't know if you're aware of that.
Yes, I'm aware of that. I'm very familiar with what Marshall Excelsior is doing, and I welcome that. Okay, I think that's a great idea, but it's just come on the market.
No, sir, it's been on the market for several years now.
Okay, well, gee. The fact is that there are very few of them installed, okay?
Also, when you say in here that except for rail cars where it is much larger, NFPA actually specifies it's a 54 drill size for all of those, so I wasn't sure if you might be confusing the outage with the sample valve that's on the rail car?
No. I'm familiar with rail cars, and there's a much larger outage gauge on rail cars.
Okay, well, I'd respectfully disagree.
That's okay. That's okay.
Again, I am a bit concerned about on slide number 24, the emissions that you're citing, and furthermore on slide number 28, I'm extremely concerned about the estimated cumulative releases that you're citing on that page. The ARB did a study in 1991 that cited 3 tons a day of emissions in the propane industry. The PERC did a study 2005 where it cited 5 tons a day. Both of those studies assumed that we were selling more gallons than we are today. Therefore, I would argue that based on the number of gallons that are being sold in the California market, the adoption of low emission equipment throughout all phases of the transfer process, and the improved education that we're giving people in the field, that the emissions are actually far, far, far lower than what you're estimating. And that's citing the ARB's own numbers.
I'd like to address that.
Go for it.
I knew you were going to say that, okay? The study that was conducted in 1992 was conducted based on phone surveys, was conducted on, let's see if I remember exactly the wording, phone surveys, questions asked of the Western Propane Gas Association, and from surveys and from available databases. These were 2 very large companies that did the study who never got off from behind a desk. So they never went in the field, and this was a paper study. Okay, and the information that was received, from my understanding of the folks who did the actual work, was information they received from the industry. There was no third-party objective review of what was actually happening. The 2005 study that you cited, I think that you cited, is an excellent step in the right direction. But again, they were using K-factors that were not known what we're talking about. And in order to get the numbers for forklift cylinder refills and stationary tank refills, I used data that was available on the net from MPGA. I used data that was available from testimony provided under the LSI-3 testimony by the Western Propane Gas Association, and facts that were cited by both ARB and AQMD. So I can back into those numbers. If you wish, I can go through them if you'd like to. If you want to.
Go.
If you'd really want to. Okay, absolutely.
150 tons a day is an astronomical amount of fuel that would be disappearing into the atmosphere, and we're not selling
I'm glad
that
you
much.
feel that way. I'll quote you. I like that.
Well, with all due respect, we totally acknowledge that we have a fugitive emissions issue, but the numbers that you're citing, we believe, 50 times higher than the actual issue based on the number of gallons that the American Petroleum Association is reporting that we sell every year.
Well, I respect that opinion, okay? But I want to go through some numbers with you, okay?
Oh, be my guest, sure.
All right.
When on slide number 32, did you mention how much one of these devices would cost?
We don't really know like what it would cost right now because we have not. We've made a couple of pre-manufacturing prototypes. We have a rough idea what we're looking at. We think we're somewhere around $500, but we don't know yet.
Okay.
This is not a formal quote in any means. This is just a guess, okay? Just to give you an idea, ballpark idea.
For $500?
Yes, that's what we're looking at.
Okay. On slide number 33, when we're talking about the specifications, the bubble level that I saw the bubble level was actually on top of your device.
Right.
Is there any discussion about if the tank itself has to be bubble level?
No. As a matter of fact, the tank doesn't. As long as you have the line and the line is straight, as long as the tank comes up, you would know it. Right. What you worry about is where the liquid is. The purpose of the bubble there is to tell you whether or not you are in line with whichever way the liquid is going to rise.
And so we're relying on someone to make the line. They have to do their homework and make sure that they get the line proper. Otherwise, they could have a problem.
The bubble level tells you when you're aligned.
Right, but the actual line that they have to set on the tank. Correct?
Yes. At the beginning of the geometry of the tank is known. They know on the plate what the diameter of the tank is, and they know what that's all you really need. What the shape of the caps is. They know whether it's elliptical or they know whether it's spherical. With that knowledge, you can very accurately calculate what the volume is within 0.5%. And it takes one time. With this instrument, you actually get a Taylor's tape that tells you exactly how far that line will be, depending on the tank. So it's very user-friendly. Once you have to draw that line or make a point. Afterwards, you don't need to worry about it. If you want to go to 80% or you mark it 70, wherever you want to mark it.
Okay.
It's essentially like a strapping chart.
Okay. Slide number 39, just again to reiterate, bullet number 2, the Refueling procedures, we are training people in the field to again not rely on the outage gauge. Also 39, the third bullet point, I'm again questioning, we can have the discussion offline regarding the accuracy of the numbers, but
well,
obviously.
Let me quickly address this. The 45 comes by adding those two numbers that we're fairly certain of, okay?
Okay. And finally, you answered the question for number 40. However, I would also argue that there are a number of different pieces of equipment, low emission equipment, and again, the outage gauge with the 72 drill hole that are available that could also help with this problem as well. So when it comes to cost, we could definitely, there are cheaper ways that we could address this issue. And yeah.
But when you're looking at the valve, that particular gauge, you could do the replacement of that valve, you're looking at, let's say, $5, okay? Let's use a round number. It's probably more, but let's say it's $5. Each dealer has at least 1,000 tanks to deal with. So to convert to that one, he's looking at $5,000. You can do this for 1/10 of that, and you have no emissions. So, gee, which one would you take?
What if your device fails?
It can't, because
it can't. Oh, come on!
Look,
with all due respect.
maybe. What if my device fails? Well,
what if the batteries? What if the line is drawn wrong? This outage gauge is there for a safety reason. The federal and state codes.
You can still, at the end, use the outage gauge to see whether you're 80% or not. You can still use it. The outage gauges are not going away. You keep them there.
I appreciate that, but
so
basically you're suggesting zero emissions, but you're also saying that somebody could use it if they wanted to. Therefore, we're back to the emissions issue again.
Well, there's a huge difference between having the thing open for the whole refill and doing a spritz test if you really want to do it.
And
if
like
you
I
don't
said,
question it.
We're now training people in the field to only use it as that spritz test.
Yeah, but it's not what's happening. That's the fact. And you cannot rely on it alone. The problem is You cannot rely on it alone. That's part of the problem. Okay?
Okay. Well, I thank you for your indulgence.
Sure.
Thank you very much for that spirited round of questions. Are there any more questions?
Yeah.
Do you have a
Alex,
favorite slide?
do I have a favorite slide? Sure. Let me go back. Slide number 31.
31.
Or any of those showing the gauge.
Okay.
So I guess I had two questions. The first one is so you don't need one of these for every tank. It would be just one
No,
of
you
these for every
carry
truck.
You carry it in the truck.
Okay, and then he goes and sticks that on just before he starts the
Right.
pump.
It's part of the, instead of opening the outer gauge, you put this on.
Okay, and then I guess I kind of missed the principle of operation. Is this
Well,
ultrasonic?
the slide, it's ultrasonic. It
Okay.
uses two ultrasonic
And
techniques.
so it detects when there's a different reflection back from the.
One of them is a bounce, the other one's something called LAM waves.
Okay.
Waves that are actually in the wall of the tank that change as the tank is being filled.
As the level gets close to the
Exactly.
sensor. Okay, very good. And I was intrigued by, Leslie's question about what if it fails. It seems to me that if it fails, it probably would fail so in a noticeable way. I mean, it wouldn't turn on.
Wouldn't work.
Wouldn't work. Okay. And then the operator should be monitoring it anyway, and he says,
Right.
geez, I know it's getting close to being full. I've been here a long time, and it's not showing anything. So,
What happens if your TV doesn't work?
yeah, okay.
You know it.
Okay, thank you, Alex.
Okay, Nora?
Thank you very much. I was wondering if you could talk about how you plan to incentivize the use of this device. It seems that,
You used the word I didn't hear.
how do you incentivize?
Incentivize.
Yes. So really the only person that has an incentive to have this used now would be the end user, the user of the tank, because he's the one who's losing out right now. The person that comes with the truck, it doesn't really matter that much to him, at least economically, because he's getting paid irrespective, as you say. So
Well, what's happening is that you now have a certain number of VOCs that are being released, okay? That's worth something. If you can avoid VOC releases under cap and trade, that's worth something.
So you're saying you would need additional regulation to enforce the use of these types of things?
VOC currently are under regulation. It's not something new. We're not talking about something that's not already a criteria pollutant. So the smart propane dealer, or whoever it is that's distributing the product, would want to minimize this and capture the revenue from not putting out in the environment these VOCs, and they add up to quite a bit. So their sources of revenue would not only be from the sale of the product, but also be from the fact that they do not put that they clean up the environment, and for that they get credit. Up to now, there was no way to get credit for that. Nobody knew what they were, essentially, or they had the wrong information. So it's taking advantage of cap and trade. Of VOCs, which is smart precursor, is it not? Thank you.
Yeah, I just have one real quick question on the technology there.
Did I
I
answer?
don't even know if we need this, but so it basically works like a stud finder, right?
Beg your pardon?
It works like a carpenter's stud finder.
Yes, it's essentially,
Okay.
well, not really, because you're on the stud finder, you move the stud finder to find it,
Uh-huh.
where in this case, the liquid finds you, because you put it ahead of time.
Right, okay.
But essentially, it's the same principle.
And what, you said two different ultrasonic techniques. Is that proprietary, or could you explain that further?
Well, right now, we're in a patent pending mode.
Okay.
thing, So essentially,
Proprietary secrets at
well,
that point.
it's essentially what it points. We use two techniques. One of them, we measure a variation in sound in the wall, within the wall itself,
Okay.
as the liquid goes up. And the other one, we bounce a signal across to the other side of the tank.
Now, why is, seems to me that the only failure modes, to bring that up again, would be pretty much the user not entering the right data.
Yeah,
Right.
but we avoid that. We completely avoid that by knowing, I come to tank number 42.
In other words, the device itself seems to be redundant and inherently pretty bulletproof,
Right.
but the safety factor of overfilling a tank might be breached if the guy didn't enter the right data, if he made an
No,
operator error.
He doesn't need to enter the right data.
What about the thickness of the shell?
No, to begin
Stuff from the
with,
nameplate.
somebody does an inventory of the tanks.
Uh-huh.
And you know that tank number 42 has this wall thickness.
Oh, so it's going to be programmed in.
It's going to have a
ahead of
lookup
time.
table.
Okay.
You go to tank number 42, you key in 42. He could key in the wrong tank number.
Yeah, that's what I'm
He
getting
could key in the
So,
wrong
okay,
tank number.
but anyway, I just wanted to get that through so I can ask the next question. Where does tank thickness come in the operation? Is that one of the two modes?
Yes.
Somehow?
Yes.
Through the intensity of the ultrasound or something? Or,
Um,
in other words, it has to get through the.
It has to go through the wall,
But you don't want it to be too loud because it'll be shooting.
echo all over.
All over the place. Okay, gotcha.
You got it.
Sounds pretty cool.
It is. Thank you.
All right, that's good enough for now.
Is there any other questions here? I have a question from the web. I think we've already covered most of this, but
Questions from the web. Glasses. Glasses. Although I was a pilot, I can't see like I used to. You're demonstrating what appears to be a developmental product as a solution to our so-called outage gauge problem. What are your commercialization plans? When will you gauge being production and purchase quantities available to industry? What will be the price? How do you keep the operation simple for the propane delivery person? Bill Platts. Good questions. It is a pre-manufactured, I'll answer each one of the questions. It is a developmental product, but it's the last developmental phase. It's what's normally called pre-manufacturing phase. The product is now ready to be manufactured on a large scale. As a matter of fact, we're looking for somebody to make it for us or somebody to license the technology. That answers the commercialization plans. We can either make it available through an existing distributor or we'll make it available ourselves. When will your gauge be in production and purchase quantity available to the industry? Clearly within a year. What will be the price? We think around $500. How do you keep the operation simple for the propane delivery person? I think we covered that, but I'll go through it again. There has to be an initial investment made in making a list of the tank thicknesses and their diameters. And that lookup table needs to be prepared for the tanks within the territory. And then that information is keyed into the device, and then that's it. I think I've answered. Thank you.
I
Thank you
think
for
we
the
have
question.
maybe just one last question off the web from Andrew Lee from AQMD.
You mentioned cost-effective means to control on the releases. What is a cost-effective range? I wish I understood what the cost-effective range meant. I'm not sure I understand what that means.
Usually, cost effectiveness refers to dollars per ton of pollutant removed.
Well,
So that would be like the operating purchasing cost and the operating cost of the device divided by how many tons of pollutant are we removing from the
I
environment.
can't do that off the top of my head.
Well, basically, you take $500 times the number of devices out there,
Right.
divided by your 45 tons.
Well, how many bobtails there are and figure it out. Okay, what criteria we used to obtain this again? Is the device permanently attached to the tank? No, it's not. It's portable. It attaches with a magnet. Sorry I couldn't answer the other two. Well, there it is.
Okay, I think that's all the questions we have for now. I'd like to thank Mr. Spatter very much, and I think we'll try to make sure that all these questions that we've received will be answered in the final report, which will be out
Okay.
shortly.
If there are any more questions, please feel free to send them. We'll be happy to answer them.
Thank you very much.
Thank you very much for the opportunity. Thank you very much.